right, so we are looking at number 1. The problem, the ordered pair that they give you is 3, 2. And the equation that they give you is y equals 3x minus 2. Okay, remember we're putting this into point slope form to be able to solve it. So the first thing you do is write down your equation or your formula for point slope form. All right, and then there are 3 things that we will pull out of this to be able to substitute into point slope form. That is your x1, your y1, and your slope, which will go in for m. Okay, your x1 and y1 are both located in the ordered pair, which is 3, 2, and we know that the first number in an ordered pair represents your x, and the second number in an ordered pair represents your y. So the first y will remain y because we need it to remain a variable so that it gets transferred down into the problem into slope-intercept form. It will not go anywhere. You will not do anything with it. It will remain right where it is. Okay? y1 is located in the second number of the ordered pair, which is 2. M is your slope, and as we know, your slope in y equals mx plus b, I'm looking right here, is located in front of your x. So the slope of this equation is going to be 3. Okay? The first x within the parentheses is going to remain x, and x1 becomes 3. Once you get it to this problem, you will then solve it by distributing the 3 out to the x. 3 times x is 3x, and 3 times negative 3 is negative 9. Y minus 2 will remain the same on the left side. Now the only thing you have to do is you see it's already becoming y equals mx plus b, and as you see, you need to get rid of the minus 2 by adding 2 so that y will be by itself. Add 2 to the right side, and you'll be left with y equals 3x minus 7. Okay? And then once it's in y equals 3x minus 7, that is your slope-intercept form, so you are done with that problem. Okay, so that is what we do when it asks us to write an equation of the line that passes through the given point and is parallel to the graph of the given equation. As you can see, the given equation is 3x minus 2. Once again, looking up here, and our new equation, once we get done, is 3x minus 7. The 3x and the 3x in both equations mean that it's parallel. The negative 2, which is your y-intercept, and the negative 7, which is your other y-intercept in the second equation, means that they start at different points, and that makes them parallel. If they were identical, it would be the same line. Okay? So that's what happens when they ask you to write an equation that passes through the given point and is parallel to the graph of the given equation. All right, so the next section asks whether the graphs of the given equation are parallel, perpendicular, or neither. So what we have to do in this circumstance is we have to get both equations into slope-intercept form so we can compare their slopes, which is located right before the x. So on number 7 on page 159, the first one is y equals 4x, oh gosh, sorry, 4x plus 5. The second one is negative 4x plus y equals negative 13. Sorry, my stylus isn't working. Okay? On the first one, y equals 4x plus 5, it's already in mx plus b format. Okay? So if it's already in y equals mx plus b, which is slope-intercept, you can already identify the slope, which is located in front of the x, and your slope on the first one would be m. There's nothing that you have to actually do to this problem. Okay? On the second one, it is not in y equals mx plus b format, and so you have to move something away from the y. The y is already located on the left side. However, it also has a minus 4x on that side as well. We need to bring that 4x to the other side to make sure it's in the right format. These will cancel out. You'll be left with y equals, now you have positive 4x minus 13. Now that it's in the right format, you can compare the two slopes in both equations. In this circumstance, both equations are equal. The slope is equal, which means that the lines are parallel. Okay? And then also, let's look at one where the lines are not parallel, so you'll have that to work on as well. Number 8, y equals 7/9 x minus 7, and then y equals negative 7/9 x plus 3. Okay? When you look at these equations in slope-intercept form, the first one has a slope of 7/9. Okay? The second one has a slope of negative 7/9. At first glance, you would think, oh, they're opposite, so that means they're perpendicular. But to be opposite reciprocals, which is what they have to be for it to be perpendicular, is you have to actually change the sign and flip the fraction. So 7/9 and negative 7/9 are not opposite reciprocals. So that means that they are not perpendicular. It also means that they are not parallel because they are not identical. What it does mean is that your answer would be neither. Okay? For this to be perpendicular, the first slope of 7/9 would have to change to negative 9/7 in the second equation. Okay? If it were, then that would mean that it would be perpendicular. All right? Any questions?
No, ma'am.